Now, today we're going to start with virtual networking. This is module 4. So these sections are going to talk about virtual networks, IP addressing, network security groups, Azure Firewall, Azure DNS, and we're going to do some lab around that. So let's have a look how Azure Network works. Now, when we create any Azure resources, for example, we create one virtual machines and we'd like to communicate with another virtual machines. So we need to have a VNet. We need to have a VNet. VNet is similar to switch. This is VNet. Let's say we put VNet A. So if we'd like to connect these two PC, this is, let's say, PC, or I put VM1. This is VM2. Oops. VM2, this is VM1. And we can connect these two VM with this VNet. VNet is similar to switch. If you connect with this VNet, and after that, if you do some configurations for this VM, they will be able to communicate with each other. Now, if you'd like to create another subnet or another network or another VLAN, let's say pretty similar to VLAN, if you want to create another network, then we need another VNet. So this is VNet B. And we may have one PC. This is, let's say, VM3. VM3 is connected with VNet B. And if we'd like to establish the connectivity in between two VNet A to B, we can establish the VNet pairing. This is called VNet pairing. And all these things is happening in one region. So when you create these resources, VM1, VM2, VM3, VNet A and B, all of the resources, they will be part of a particular region. Let's say this is East US, like that. Now, if we have another region, let's say we have another region, this is West US. And we have some resources over there. We may have VNet, and then we may have virtual machines. This is VNet C. And let's say this is VM4. So they are located in different regions. So if you'd like to connect that regions with these regions, with this network, we can do the networking, right? One regions to another regions. It's kind of, we can create, a VPN tunnel or site-to-site VPN. In order to do that, we need to have a VPN gateway. Gateway is similar to routers. Gateway is similar to routers. Like that. So we call it gateway. And this is another gateway. So we need to have a gateway if we'd like to go out from our region. So from here to there, we can have connectivity. Like that. So multiple regions, we can establish the connectivity. Then if you have a infrastructures, let's say on-premises infrastructures, we have something, on-premises. This is on-premises infrastructure. On-premises infrastructures, we may have local area network. And if that local area network want to contact with Azure network, we can create site-to-site VPN. And for that, we need just one routers. A router should be VPN capable router. And then we can establish the connectivity from on-premises that router to all the way Azure gateway over there. So this is kind of site-to-site. This is actually called Azure to site. Mostly we call Azure to site connectivity. So this sort of connections we can do. In this way, wherever our resources will be able to connect from on-premises to cloud or cloud to another cloud like that. So today, majority of the steps we're going to discuss around that. We're going to look at how they are connected. So VNet B should be connected with this gateway. In this way, this region, they'll be able to communicate with other region and this on-premises services. So pretty much we're going to discuss majority of the steps around that. Now, first topics, we're going to look at virtual networks. Part of that, we're going to discuss Azure networking components, virtual networks, subnets, implementing virtual networks, and we're going to create virtual networks. Azure networking components, we have virtual network, load balancer, applications gateway, traffic manager profile, virtual network gateway, and virtual wide area network. So we have some services in the cloud related with networking components. Adopting cloud solutions can save time and simplify operations. Azure requires the same types of networking functionality as on-premises infrastructures. Azure networking offers a wide range of services and products. Now, virtual networks. We have virtual machines, and virtual machines will have NIC card, and this NIC card will have some IP addresses, and those IP addresses will be from some subnet. And we have the virtual network. We can connect with on-premises or other virtual network. So virtual network, basically, that's a logical representations of your own network. Create a dedicated private cloud only virtual network. Securely extend your data centers with virtual network. Enable hybrid cloud scenarios. These are the options we have. Now, subnets. So virtual network can be segmented into one or more subnets. Subnets provide logical divisions with your network. Subnet can help improve security, increase performance, and make it easier to manage the network. Each subnet must have a unique address range, cannot overlap with other subnets in the virtual networks in the subscriptions. So subnet will be related with our particular network. For example, if we have VNet A, we'll have one subnet. If we had VNet B, we'll have another subnet. And if we need more subnet, we can have multiple VM. So when you create any networking components, Azure will provide one subnet, but if you'd like to use our own subnet, we'll be able to change as well. Now, implementing virtual networks, create new virtual networks at any time. Add virtual networks when you create a virtual machines. Need to define the address space and at least one subnet. Be careful with overlapping address space. So when you create the virtual network, then you need to take care of name, VNet, and area. So we're going to create this one and later on have a look how it works. Second sections, IP addressing. This section is going to discuss IP addressing, creating IP addresses, public IP addresses, private IP addresses. IP addressing, VNets, on-premises network, VPN gateways, and express route. So around that, we need IP addresses. We have public and private addresses. Private IP addresses used within an Azure virtual network and your on-premises network when you use a VPN gateway or express route circuit to extend your network to Azure. It's saying that if you have a local area network on premises, and also if you have any Azure internal network, then we'll have this private address. And we can connect our private subnet with cloud with this VPN gateway and express route. There are the two methods with that we can establish the connectivity. It's similar to site-to-site VPN. And public IP addresses used for communications with the network or internet, including Azure public facing services. For example, if you create any virtual machines, it will have private addresses and it will have public addresses. So if you'd like to remote logged into that virtual machines, you can use RDP. With that, you can log into that virtual machines. So in order to log in via internet, that virtual machines must have to have public IP address. And internally, that device will have private IP addresses. Now, creating public IP address. By default, Azure will provide one public addresses for your resources. But if you'd like to create one, you can create a public IP address as well. Available in IPv4 or IPv6 in both basic or standard SKU. Available in dynamic, static, or both, depending on SKU. Is a zone redundant, not mixable or immutable. So range of contiguous addresses available as a prefix. So we can create this IPv4 basic and we can create public IP address. Once we create the public IP address, this address will be able to use in different scenarios. Public IP address, virtual machines, we have NIC card, we have dynamic, static. So it can get the public IP address dynamically, or we can assign static IP. Load balancer, front-end configurations. We can have dynamic IP load balancer allocations and static as well. For VPN gateway, we need gateway IP configurations, and we'll get that one dynamically. So we cannot assign that gateway IP address manually or statically. Applications gateway, front-end configurations, dynamic and static, both way we can have that applications. So a public IP address resource can be associated with virtual machines network interface, internet-facing load balancers, VPN gateways, and applications gateways. So private IP address, we have virtual machines. Virtual machines, we can have public IP address, internal load balancer, we can have applications gateway, we can have this private address. And you can see that for on all context, both a dynamic and static way, we can get the IP address. So dynamic is the default options. Azure assigns the next available unassigned or unsubbed or unreserved IP address in the subnet's address range. And static is select and assign any unassigned or unreserved IP addresses in the subnet's address range. Okay, so these topics we have looked at. Now, next sections, we're going to look at network security groups. Part of this one, we're going to discuss network security groups, network security groups rules, NSG effective rules, creating NSG rules, and we're going to look at how it works. So NSG is network security group is kind of access control list. So its main job is it will allow some traffic, deny some traffic, allow some port, deny some port. Those are the things will be done by this network security groups. Now, network security groups will limit the network traffic to resources in a virtual network, contains a list of security rules that allow or deny inbound or outbound network traffic, can be associated to a subnet or a network interface. So when you create any virtual machines, automatically there will be some NSG rules associated with that virtual machines. But we can create this network security group and we can attach with our virtual machines, subnet or NIC card. Now, NSG rules, this is the network security groups. We have inbound rules and outbound rules. This is similar to Cisco access control list. It will allow some traffic, it will deny some traffic. So for example, it will allow certain port number, protocol, etc. Something coming in or something going out, that is called outbound security rules. So same thing, port number, protocol, we can allow or we can deny. So security rules in NSGs enable you to filter network traffic that can flow in and out of virtual network subnets and network interfaces. There are default security rules. You cannot delete the default rules, but you can add other rules with a higher priority. Priority means you see 165,000, 65,001, 65,500. So lower the priority, that policy will be on the top and that will apply at first. Now, NSG effective rules. NSGs are evaluated independently for the subnet and NIC card. An allow rule must exist at both levels for traffic to be admitted. Use the effective rules linked if you're not sure which security rules are being applied. So by default, there will be some allow rules, and in this way, we'll be able to connect to that, that particular system. So how to create these NSG rules? Select from a large variety of services. We have a service, we have a port range and priority. Service is a destinations, protocol and port range for this rule. Port range Single port or multiple ports we can have in here. Priority, lower the number, that higher the priority, so that policy will apply at first. Then we can have name for it. If we like, we can put some descriptions. Because if you have many rules, that time you can see in details. If you write down some description, then you understand that this rule has been configured for what purposes. Okay. Now access the NSG blade, add a new NSG, explore inbound and outbound rules. So this configurations you're going to look at soon. So another topics we have Azure Firewall. So part of this one, we're going to discuss Azure Firewall, implementing firewalls, firewall rules. So firewalls is works pretty similar to actual internet-facing routers we have in our local area network. It will work exactly like that. So we can have Azure Firewall, and that will actually filter many traffic, whether it's coming from on-premises or in the cloud traffic. So this Azure Firewall will verify those connections. So this is stateful firewall as a service. Stateful means it will keep track of the informations. It will save the informations. Built-in high availability with unrestricted cloud scalability. Create, enforce, and log applications and network connectivity policies. Threat intelligence-based filtering. Fully integrated with Azure Monitor for login and analytics. Support for hybrid connectivity through deployment behind VPN and express route gateways. So it has a lot of advantages. It can do threat filtering. You can monitor as well. You can get some data as well. So Azure Firewall, it has a lot of security functionality. Now implementing firewall, create the network infrastructures, deploy the firewall, and create a default route, configure rules. So this is the Azure Firewall subnet, and we have some configurations. That means some workload we allow, some workload will deny. And this side it says PP means public IP. This means public IP, and they are all under virtual network. So firewall rules, once we deploy our firewalls, we'll be able to create some rules such as NAT rules. Configure dynamic NAT or DNAT rules to allow incoming connections. Network rules, configure rules that contain source address, protocols, destinations port, and destinations addresses. And application rules, configure fully qualified domain names that can be accessed from a subnet. So these are the things we have under firewalls. We'll be able to configure these rules. Okay. So let's discuss Azure DNS, and then later on we're going to look at some labs. Azure DNS, part of this one, we're going to discuss domains and custom domains, verifying custom domain names, Azure DNS Zones, DNS Delegations, DNS Record Sets, DNS for private domains, private zone scenarios. So these sort of things we're going to look at. So what is DNS servers? So basically DNS servers or services is provide the name resolution. Name resolution means when you write down any name such as www.google.com, so our device need to translate that name to IP address, because our system or device, they only understand the IP address. So DNS actually keep track of name and IP address informations inside the DNS zones. So many enterprise network, we have these DNS servers. If we have Active Directory domain services, we must have to have a DNS servers on that network. So many companies, they use these DNS services. But when we use any services in the cloud, then we can have this Azure DNS servers, and we'll be able to communicate some, configure some features. Now, domain and custom domains. When you create an Azure subscriptions, and Azure AD domain is created for you. So these things happen automatically. The domain has an initial domain name in the form domain name dot on Microsoft.com. You can customize and change those name. After the custom name is added, it must be verified. It's kind of like Azure will provide you URL from their sites, but if you'd like to have your own URL, then you can kind of forward this information to your URL. This is custom domain names, and that is Azure domain names. So we can connect our resources with custom domain name. Usually, like if a company have their own name, they want to have their name in the domain. And if you'd like to use your own custom domain, then some of the DNS configurations that need to be written inside the Azure side. Verify custom domain name. Verification demonstrates ownerships of the domain name. Because when you try to add any DNS servers, you need to verify. Especially when you change the name, we must have to verify our domain name. Add a DNS record that is provided by Azure into your company's DNS. Azure will query the DNS domain for presence of the record. So that DNS domain will have the resource record. Resource record, for example, this is a record. Oh, sorry, this is a record type is text record, but under that you have this is host name, destinations, address, and TTL value, because after that time, this information should get refreshed. Azure DNS, we can create Azure DNS in this way. A DNS zone hosts the DNS records for a domain. The name of the zone must be unique within the resource group. So where multiple zones share the same name, each instance is assigned different name server addresses. So root and parent domain is registered at the registered and pointed to Azure name servers. Now, DNS delegations. When delegating a domain to Azure DNS, you must use the name servers names provided by Azure DNS. Use all 4. Once the DNS zone is created, update the parent register. For child zones, register the NS record in the parent domain. So it's saying that Azure has multiple DNS servers, 4 DNS servers. So from your domain, you need to say name resolutions can be done with these name servers. So simply we can manage the DNS servers, which is associated with that name. DNS record. So usually we create DNS. I'll just start my virtual machines. I'll show you from the local servers as well. A record set is a collection of records in a zone that have the same name and at the same time. You can add up to 20 records to one record set. A record set cannot contain two identical records. Changing the drop-down type changes the information required. So that means you cannot have duplicate record, right? Every record need to be different name or different things. This is kind of helloworld.azureadminic.org. This is one of the DNS informations. And under that, we have a record. And time to live is after 1 hour. And this is the default IP address. So DNS private domains. Use your own custom domain names and provide name resolutions for VMs within a VNet and between VNets. So with your custom domain names, you can provide name resolutions for your virtual machines in the cloud. Automatic hostname record management removes the need for custom DNS solutions. Use all common DNS record types available in all Azure regions. So this kind of records will be able to create and maintain. You can see that these virtual machines request IP address for these sites, and DNS servers respond with the private IP and connect to the resource with VM. Another network using this private IP. So basically, this one is db.contoso.local. So once you got the IP, then this VM will be able to access that VM, which contain these database informations. Private zone scenarios. DNS name resolutions is in VNet 1 is private and not accessible from the internet. So DNS queries across the virtual networks are resolved. Reverse DNS queries are scoped to the same virtual network. So basically, if we create any name resolutions, DNS resolutions in VNet 1, it will be private. It will not be accessible from outside. So around that area, we're going to look at some labs. Module 5, inter-site connectivity. Part of this one, we're going to look at VNet peering, VPN gateway connections, express route and virtual WAN, and then you're going to do some lab around that. Now, VNet peering. Part of this one, we're going to discuss VNet peering, gateway transit and connectivity, configure VNet peering, service chain, and then you're going to look at how this VNet peering is functioning. So VNet pairing connects to Azure virtual networks. So that means we have a region 1 and region 2. So inside the region, we can have pairing, or one region to another region, we can have global VNet pairing as well. So regional and global paired networks use the Azure backbone for privacy and isolations. You can pair across subscriptions, easy to set up, seamless data transfer, and great performance. What is gateway transit and connectivity? Gateway transit allows paired virtual networks to share the gateway and get access to resources. Let's say we have VPN gateway, use remote gateway, and on-premises services. So gateway is important. Gateway is same like a routers. It can provide you the connectivity to different subnet. No VPN gateway is required in the paired virtual network. That means once you paired, it will work as like VPN, but you do not have to configure any VPN. Default VNet pairing provides full connectivity. IP address spaces of connected network cannot overlap. That means when you have subnet, like one subnet here, you can see another subnet here, another subnet here. This different subnet, when you create something, they cannot be overlapped. So for this one subnet, for this one another subnet, for this one another subnet. So that's actually VNet A, VNet B, and hub VNet. It's kind of switch 1, switch 2, switch 3, like that. Configure VNet pairing, allow forwarded traffic from within the virtual network into your virtual network. So within the same virtual network, we need to allow this traffic. Allow gateway transit, so allows the peer virtual network to use virtual network gateway. We are saying that saying one VNet, we're saying this VNet to communicate with that gateway via this VNet. Use remote gateways, allows the virtual network to use another virtual network's gateway. So these things we need to permit. If you select allow gateway transit on one virtual network, then you should select use remote gateway on the other virtual network. So it's kind of, we're saying this one to use that one via this switch. And when you go to this gateway, we need to allow that VNet to go out from this gateway. It's kind of like VNet A will say, please use the remote gateway. And from the gateway, we can say, allow the remote VNet. In this way, we can allow that particular VNet to communicate outside. Service chaining. Leverage user-defined routes and service chaining to implement custom routing. Implementing a VNet hub within network virtual appliances or VPN gateway. Service chaining enables you to direct traffic from one virtual network to a virtual appliances or virtual network gateway in a paired virtual network through user-defined routes. Now, Let's have a look some configurations. We need to configure some VNet and VNet pairing.